In this chapter, we're going to be looking at more complex identities, how we simplify identities, and how we verify identities. But just from what we did back in Chapter 4, we need to review our basic identities that we are going to use to simplify these more complex identities. And there are 5 different categories that we've got: the reciprocal, the quotient, Pythagorean, cofunction, and even-odd identities. We looked at all these in the last chapter, so this will just be a quick review, making sure you understand what these different identities are. These do need to be memorized, so you might want to have these down before we come to our quiz or test. First of all, reciprocal. The reciprocal identities are the ones that are paired as 1 over a relationship to another. So 1 over something. With sine, sine is related to 1 over the cosecant. So sine of theta is 1 over the cosecant of theta. Conversely, the cosecant of theta is going to be 1 over the sine of theta. The second reciprocal pair we had was with cosine and secant. The cosine of theta was 1 over the secant of theta, and the secant of theta is 1 over the cosine of theta. And then finally, tangent and cotangent. Tangent of theta was 1 over the cotangent of theta, and the cotangent of theta was 1 over the tangent of theta. The 6 reciprocal identities you were responsible for. The second group were the quotient identities, and there were only 2 quotient identities, tangent and cotangent. And we saw that the tangent is the same thing as the sine divided by the cosine, and the cotangent was the same as cosine over sine. The third group that we have were the Pythagorean identities, and the one that we memorized was the sine squared plus the cosine squared is equal to 1. And then we found the other 2 identities by dividing all the way through by sine and then all the way through by cosine. So if I took this expression here, sine squared plus cosine squared is equal to 1, and I divide through by sine squared divided by sine squared is 1. Cosine squared divided by sine squared ended up being the tangent. Actually, let me rephrase that. Cosine divided by sine is going to be the cotangent. And then 1 over the sine was going to be the cosecant. So we had 1 plus cotangent squared is equal to cosecant squared. The other one we got from dividing everything through by a cosine, and we got 1 plus tangent squared is equal to secant squared. So our 3 Pythagorean identities. The fourth group were the cofunction identities, and the cofunction identities are the 2 identities that if we've got angles, they need added to be 90 degrees or pi over 2. And the way we looked at cofunction were they had the words co in front of it. So sine was paired with cosine, secant was paired with cosecant, and tangent was paired with cotangent. So the cofunction identity that we had was the sine of pi over 2 minus theta. That was the same thing as the cosine of theta. So sine was paired with cosine. And we could go in the other direction as well. The cosine of pi over 2 minus theta is equal to the sine of theta. The second pairing we had were secant and cosecant. So the secant of pi over 2 minus theta equaled the cosecant of theta. And then going in the opposite direction as well. The cosecant of pi over 2 minus theta equaled the secant of theta. And then finally, the tangent was paired with the cotangent. The last group we had were even and odd identities. And we just had to remember which ones were even and which ones were odd. And with my trig functions, the ones that were even were cosine and secant. And then the ones that were odd were sine, cosecant, tangent, and cotangent. So if I wanted to write those in an identity format, I know that my odd function follows the format f of negative x equals negative f of x, and my even function format is f of negative x is equal to f of x. So I'm just going to follow that pattern, but instead of x's, I'm going to have sine, cosine, tangents, and so forth. So for the odd, we know sine, cosecant, tangent, and cotangent are odds. So the sine of negative theta is negative sine of theta. The negative sign just comes out in front. The cosecant of negative theta is negative cosecant of theta. The tangent of negative theta is negative tangent theta. And the cotangent of negative theta is negative cotangent theta. So that negative sign just comes out in front. With my even functions, the negative sign goes away. So the cosine of negative theta is the same thing as the cosine of theta. And my other even function was secant, so the secant of negative theta was equal to the secant of theta. So those are all the identities that we learned back in Chapter 4 that you're responsible for going into Chapter 5. Now, with those identities, we learned last chapter that there were 3 things that we tried to do whenever we simplified something. So if I gave you a long identity, we drew that chasm between the two sides along the equal sign, and we only manipulated one side. And there were 3 rules we followed. The first one was convert everything to sine and cosines. The second was finding a common denominator and making a single fraction. And then the third thing was foiling. However, there's a lot more different algebraic techniques that we can do. And that's what we're going to look at in this section. The fourth option we have is we can factor out an expression, pulling out a single term or doing Mach factoring. So for example, if somewhere in my expression I had tangent squared of theta plus 3 tangent of theta plus 2. This would be a multiply, add, choose situation where I want to know what are the factors of 2 that add up to 3. And if I do that, I would have the tangent of theta plus 2 and the tangent of theta plus 1. Those values add to be 3 but multiply to be the positive 2. That would be the Mach format in terms of factoring. We could also factor an expression using a greatest common factor. And an example of that would be, let's say I have the cosecant squared of theta minus the cosecant of theta tangent of theta. I've got a common cosecant in both pieces, so this expression can be rewritten as the cosecant of theta factored out times the quantity cosecant of theta minus the tangent of theta.